This is on mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at area and the fundamental theorem of calculus. First, let me write down the fundamental theorem, at least the important part. Fundamental theorem of calculus. Goes like this. If you have the integral, and then we have numbers here. I'll put a and b to represent any numbers of f of x, d of x, f of x dx, sorry, not d of x, equals f of b minus f of a, and notice I changed the capital F, where, and this shows the relationship between your capital F and our little f. If we take the derivative of the capital F, so f prime of x would equal to f of x. There's some other items go along with this. What's got to be true? It's got to be continuous. Non-negative, closed interval a and b, and so forth. But this is the main thing what we're going to be using. Now, these first problems don't really use that. They're wanting us to look at it from a geometry standpoint. So our first one here says, sketch a region whose area is represented by the definite integral, then use a geometric formula to evaluate the integral. One of the purposes of this is called a definite integral, where you have numbers on here. One of the purposes is to find the area. Now this 6, that's the same as like having y is equal to 6. So y equals whatever's here. So y is equal to 6 will be a horizontal line at 6. And it says from 0 to 2, which means that for finding that definite integral, we're trying to find the area between 0 and 2. So we're trying to find this area right here. Well, that's a rectangle. Rectangle, the area is length times width, or height, as the case may be. This is 6, and this is 2, so it'll be 6 times 2, or 12, which would be our area. Let's look at our second one here. We got x over 4, so that's like y is equal to x over 4. And it's from 0 to 4. Well, if I were to put 0 in here, that's 0 over 4, which is 0. So 0, 0 is one of our points. And if I were to put 4 in there, 4 over 4 is 1, so we have 4, 1. So that's the line, basically. Well, actually, let me continue it forever just so you can see it. Okay, so it goes like that. And then it's from 0 to 4. So here's 0 to 4. So what they're trying to find is this right here. It's bounded by the x-axis. Well, this is a triangle. And area of a triangle is 1/2 times base times height. Well, this distance here is 4. That'd be our base. And our height is this distance, which is 1. So 1/2 times 4 is 2, times 1 gives us 2. So 2 would be our answer. Well, let's take a look at how to use this fundamental theorem of calculus to do some of these. Here they actually give you the picture. Y is equal to 4 minus x squared. It says find the area of the region by the fundamental theorem of calculus. You can see x value y goes from -2 to 2. So setup on this, it'll go from -2 to 2. And it's 4 minus x squared dx. And this will give us the area underneath that curve. It's what's bounded by this graph and the x-axis. Now, this is actually an even function. So I could just find half of it and go from 0 to 2. And then multiply it times 2. But I'm going to go ahead and do it this way. Okay. Well, we find the integral just like normal. So 4 becomes 4x minus, we add 1 to our power, divide by our new power. So it becomes 1/3 x to the third to -2. Then we're going to plug 2 in. So I got 4 times 2 minus 1/3 2 to the third. So I just plugged in x equals 2. We're also going to plug in x equals -2. So I got 4 times -2 minus 1/3 times -2 to the third. And then you have a minus between them. It's always a minus between them. Okay, so that gives us 4 times 2 is 8. 2, 4, 8 times 1/3 is 8/3. Minus 4 times -2 is -8. -2 to the third is -8 times a -1/3 gives us a positive 8/3. And I'm going to get rid of those first set of parentheses. These second ones, you got a negative out in front. Remember, a negative out in front of your parentheses flips the sign of everything inside. So this becomes a plus 8 minus 8/3. 8 and 8 gives me 16 minus 8/3, -8/3, -8/3 is -16/3. Now this is a mixed number form, so I can take 16 times 3 is 48, plus a -16 gives us 32/3. 48. Yeah, that should be right. So that's our answer. Now you can use a calculator to get an approximate on these. It won't give you the exact value, but let's take a look at that. I don't know why I had two calculator. Oh, I guess I just had one. Okay, let's bring up my calculator again then. Thought I had two copies of it running. Okay, so I'm going to press y equals clear. I made this problem up earlier, so I already had it on there, but 4 minus x squared. So I type 4 minus x key and then x squared. Now do second trace. And you see the very last one, number 7? One looks like an integral symbol. If we choose that and press enter, it'll ask us for lower bound, lower limit. That's our -2. So we want it bounded by -2. Then asks us for upper limit. We want it bounded by +2. And then I'll give you this. As far as I know, there's no way to change that to a fraction. Doesn't mean there isn't. I just never have discovered it myself. But that gives you an approximation. Now, what I came up with by hand gave us the exact answer right here. Let me save that. What is this? Area in the fundamental theorem of calculus. Area and the fundamental theorem of calculus. 1 minus 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 1 min calculus. Page 01.pdf. There we go. Let's look at our next one. 1 to 3. And we got x squared minus 2x plus 3 dx. Okay. Add 1 to our power, divide by our new power. Add 1 to our power, divide by our new power, and then that just becomes 3x. Now let's simplify this a little bit. We got 1/3 x to the third. Those 2's cancel. We got minus x squared plus 3x and 3, 1. Okay, so we're going to plug in 3. So I got 1/3, 3 to the third, minus 3 squared plus 3 times 3, minus, plug in 1. So we got 1 to the third minus 1 squared plus 3 times 1. So our upper, we plug in upper limit, we plug in here. Our lower limit, plug in here, and subtract them. Let's see. 3 to the third is 27. Divided by 3 is 9. Minus 3 squared is 9. Plus 3 times 3 is 9. That's weird. Minus 1 to the third is 1 times 1/3 is 1/3. Minus 1 squared is 1. Plus 3. Those cancel, and I got 9 minus 1/3, negative 1 plus 3 is 2. Negative out in front, we'll flip a sign. So this becomes 9 minus 1/3 minus 2, which 9 minus 2 is 7, minus 1/3. It's a mixed number. 7 times 3 is 21, plus a negative 1 gives us 20. So we get 20/3 as our answer. And let's go plug this in calculator, see if that seems reasonable. We'll press y equals, press clear. We got x squared minus 2x plus 3. Second trace, we'll choose our 7th one, if it's 7 on yours. And we're looking from 1 to 3. So do 1 inner, 3 inner. And that seems reasonable. Now realize that we use the fundamental theorem of calculus to find area, and that says it has to be non-negative. But these can go down below the graph here, and I might even have some here. And if they go down below, then the answer you get if you evaluate the definite integral is negative. So if you come up with a negative in some of these answers, don't be shocked. Now, if we're finding area, we have to do it a little bit differently, because area, of course, is always positive. Let's look at number 5. We got integral 0 to 2 of 3x minus 1 squared dx. Now, I'm going to do the u substitution here. We got parentheses to a power, so I'm going to let u equal to 3x minus 1, whatever's inside the parentheses. Du be 3 dx. Okay, so we need 3 inside. Oops. Leaving a space there. And we'll offset it with a 1/3 out in front. Okay, so again, 3x minus 1 gets replaces that with a u. The 3 dx both get replaced by du. So it's going to become 1/3 And I'll go ahead and put x equals 0 here and x equals 2 to indicate those are our x values. And this becomes u squared du. Now we'll add 1 to our power, divide by our new power, so that becomes 1/3 u to the third. X is equal to 0, x equal 2. Now some people will switch those to u's. Instead of x's, they'll switch them to u's at that point. And you can do that if you want. There's nothing wrong with it. Now, if you got a number inside like that, you can always take a number, assuming it's multiplication, and put it on the outside. So take that 1/3, put it out there, and this becomes 1/9. Now I'm going to plug my u equals back in. We said u is equal to 3x minus 1 up here. So I'll plug in 3x minus 1. And then he switches back to just 0 and 2. Okay, so now we're ready to plug in our values. So I got 1/9 clear out in front. And I'll plug in a 2. So I got 3 times 2 minus 1 to the third minus 3 times 0 minus 1 to the third. Well, 3 times 2 is 6, minus 1 is 5, so we've got 5 to the third, minus 3 times 0 is 0, minus 1 is negative 1, so we got negative 1 to the third. Which gives us 1/9. 5 to the third is 125. Negative 1 to the third is negative 1, with a negative out in front becomes a positive 1. 125 plus 1 is 126, so we got 126 over 9. Now, those are both divisible by 3, at least. So that gives us, what, 42? Yeah, over 3. I guess they were both divisible by 9, which gives us 14? Assuming I did my basic math right. Now, let's plug this in the calculator and kind of check myself. I'm not always greatest at basic math. Okay, do y equals clear. Do beginning parentheses 3x minus 1 closing parentheses squared from 0 to 2. So I do second trace, choose the integral one. Lower limit 0, inner, upper limit 2, inner. And then we got 14. It's kind of, even if you're doing it by hand, do this to kind of get a feel for what are we finding picture-wise. Definitely help for the next section. Let me save that. Okay, let's look at our next problem. Actually, let me grab a drink here. Okay. One to 4 of 2 over 5x plus 3 dx. Now remember, for our u substitution, we have 4 possibilities. You got parentheses to a power, and if you do, you let u equal to what's inside of parentheses. You got radical. If you do, then you got let u equal to what's underneath the radical. You got e to a power, and if you got e to a power, you let u equal to the power. Or if you got just a fraction, you can let u equal to the denominator. That's what we'll do here. So let u equal to 5x plus 3. The derivative of that would be 5, and then I have to add on my dx. I got a 2 inside. I don't want 2 in there, but I can throw it out in front. And I'll put a 5 in there because that's what I want. I'm just wondering. Okay, never mind. Sometimes I try to be random making these problems up and they don't come out random. Okay, so I got my 5, got my dx. I need to offset the 5 with a 1/5 out in front. Okay, so that becomes 2/5. And I'll change these to x equals 1 and x equals 4, because these are specific to the x values. And the 5x plus 3 becomes u. The 5, the dx, 5 dx becomes du. So this becomes 1 over u du, which gives us 2/5 natural log of the absolute value of u, x equals 4, x equals 1. Now I'm going to plug my u back in. So I have natural log of the absolute value of 5x plus 3. Excuse me. I'll change these back to just 1 and 4. There we go. Now we'll plug those in. So we've got natural log of the absolute value of 5 times 4 plus 3 minus natural log of the absolute value of 5 times 1 plus 3. So this is 5 times 4 is 20 plus 3 is 23. And that's positive, so I can drop the absolute value bars. Minus 5 times 1 is 5 plus 3 is 8. And again, that's positive, so I can drop the absolute value bars. And this is basically our answer. We could merge these into a single log, make it a little bit simpler. Remember, if you have log of something minus log of something, subtraction becomes division. So we've got 23 over 8. I could take this 2/5 and put it as a power, but I think that'd just make it nasty looking. So that's our answer. I'm not going to plug this in the calculator because there's no way I'm going to get something of this form, so I can't even see if it's accurate. Now I could plug this in, get the decimal, and then plug it in the calculator and see if they match. Let's take a look at this one. Get the integral from 0 to 1 of 5 over the square root of 8x plus 1 dx. Okay. We got our different possibilities. Parentheses to a power, we set u equal to what's inside of parentheses. Don't have that. But we do have radical. So we'll set u equal to what's inside the radical, the 8x plus 1. And derivative of that, derivative of 8x plus 1 is 8 dx. Okay, so we need an 8 inside. We don't want a 5, so I'll take 5, put it out in front. And we're going to put an 8 inside, so we'll put a 1/8 out in front. So we've got 8 there, and square root of 8x plus 1 dx. So that gives us 5/8 from x equals 0 to x equals 1. And the 8x plus 1 here gets replaces that with u. The 8 dx, 8 dx gets replaced with du. So this becomes 1 over the square root of u du. Which gives us 5/8, x equals 0, x equals 1. And that's 1 over u to the 1/2 du. But we want that up on top because we want u to a power. So remember, you take something opposite of where it's at in a fraction, the sign of the exponent changes. So I take that u to the positive 1/2 up on top, it becomes u to the negative 1/2 du. Okay, now I'm going to add 1 to my power, divide by my new power. So u to the negative 1/2 plus 1 over negative 1/2 plus 1. Which gives me 5/8 times u to the 1/2 over 1/2. Remember, if you have a single fraction downstairs, you can flip it and multiply times your top part. And since it's just a number, I can actually put it completely outside of the brackets there. So we got 5/8 times 2 over 1, u to the 1/2, x equals 0, x equals 1. The 2 and 8 reduce. They're both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. So we've got 5/4 square root of u, x equals 0, x equals 1. And now we're ready to plug our u equals back in. Let's go see what in the world it was. U is equal to 8x plus 1. So I'll put in 8x plus 1. Change that back to 0 and 1. Okay. And now we're ready to plug in our numbers. So we got 8 times 1 plus 1 minus 8 times 0 plus 1. Well, 8 times 1 is 8, plus 1 is 9. So we've got square root of 9 minus 8 times 0 is 0, plus 1 is 1. So we've got square root of 1. Well, square root of 9 is 3, minus square root of 1 is 1. So that gives us 3 minus 1, which is 2, times 5/4, which gives us 10/4, which gives us 5/2. Now that one I could actually definitely check. So let's plug this in. So press y equals, press clear. I got 5 divided by second x squared for the square root, and then 8x plus 1. And I'll do second trace and choose the 7th one for the integral. And 0 inner, 1 inner. 2.5. Well, we came up with 5/2. That's 2.5. So that checks. Let me save this. Then we'll look at the next problem. Okay, let's look at this one. The integral from 2 to 4 of e to 9x minus 1 dx. Well, on this u substitution, we'll let u equal to the exponent, because you got e to a power. So u is equal to 9x minus 1. Du would be 9 dx. So I need a 9 inside, so I'll offset it with a 1/9 out in front. And these are from x equals 2 to x equals 4. We're going to replace the 9x minus 1 in our exponent with u. And here's 9 dx dx. So 9 dx gets replaced with du. So this becomes integral of e to the u du. Well, the integral of e to the u is e to the u. Now I notice on these I don't put the plus c on there for the definite integral, because we're finding a number. C is like some number we have no clue what it is, so it doesn't make any sense for the definite integral. Let's see. Plus it doesn't fit our formula for the fundamental theorem of calculus. Well, now I want to plug my u back in. What was u? U is 9x minus 1. So 9x minus 1 2 to 4. So plug those in. So I got e to the 9 times 4 minus 1 minus e to the 9 times 2 minus 1. Well, 9 times 4 is 36, minus 1 is 35, minus e, 9 times 2 is 18, minus 1 is 17. Now I can factor out an e to the 17, but I'm not sure if that benefits us a whole lot. That's our answer. Let me grab a drink here. Okay, find the area of the region bounded by the graphs of the equation. We got y is equal to 1 plus the cube root of x. Y is equal to 0. X is equal to 0. And x is equal to 8. Now if I look at the graph of this, I know what the cube root of x looks like. If you remember that from college algebra, it's just kind of looks like that. The plus 1 means it's shifted up 1. So I'll just kind of sketch it here. Something like that. That's not perfect, but it doesn't have to be perfect. And this says that it's going to be bounded by y is equal to 0. That's y is equal to 0. It's going to be bounded by x is equal to 0. That's x equals 0. And it's going to be bounded by x is equal to 8. Assuming this is 8, it's bounded by that. So what we're trying to find is this right here. While this graph isn't, it's down here, it's below the x-axis. Where we're looking, it's above the x-axis, which is what we need for problems dealing with area. So we'll do this with the integral. This go from, and it has to be with your x values. You know, here's x equals 0, this first one. So it's going to go from 0 to 8. And this is our area of 1 plus cube root of x dx. And again, that'll give us the area of what I've shaded there. Okay. So we've got 1 plus, I'm going to write that in fractional power form, rational exponents. Because you have to have it as x to a power. Okay. 1 becomes x plus, add 1 to our power, divide by our new power. That gives us x plus 1/3 plus 1 gives us 4/3. So we got x to the 4/3 divided by 4/3. Remember, if you got a single fraction down in your denominator, you can flip it and multiply times your top part. So this becomes x plus 3/4 x to the 4/3 power. 8 to 0. Now if I plug these numbers in at this point, so I'll plug in 8. I got 8 plus 3/4 times 8 to the 4/3, and 0 plus 3/4 times 0 to the 4/3, and minus between them. 0 to the 4/3 power is 0 times 3/4 is 0 plus 0 0, so all that drops away. So we're left with our first part. So we got 8 plus 3/4. Now if you remember from intermediate algebra, when you have a number to a fractional power, you can take the number in the numerator, the 4, and put it on the outside of the parentheses. So this would be times 8 to the 1/3 to the 4th power. So again, just took the numerator, put it on the outside of the parentheses. Reason we did that is because we can rewrite this in radical form now. This is the cube root of 8. Now 8 is 2 times 2 times 2. And our index is 3, which means that we're looking for a set of 3 something. Here's 3 2's. So it comes out as a single 2. So we got 8 plus 3/4 times 2 to the 4th power. So then we got 8 plus 3/4 times 2 to the 4th is 16. 4 and 16, this gives us 12. So we got 8 plus 12, or 20. Definitely that's something that could check. So let's go plug this in and see. So press Y equals, press clear. I got 1 plus the cube root, which is underneath the math menu. And I choose the cube root one, number 4 on my calculator. Put the X key in. Now do second trace. Choose my integral one. And this is going to be from 0 to 8. So do 0, enter for the lower limit, 8 for the upper limit, enter. And, well, the calculator gave us a wrong answer. It has some rounding issues that came in. This is an approximation. Ours is that right answer, the 20. Huh, I didn't expect that, to be honest. I know when you get into some more complex ones you get that, but I didn't think this one was that complex. But obviously the calculator thought it was. Okay, let's look at this one. Number 10. It says find change in costs C, or the revenue R, or a profit P for the given marginal. So whichever one the problem deals with. In each case, assume that the number of units X increases by 3 from the specified value. Okay. dr dx is equal to 50 minus 4x, and then x is equal to 20. So this is going to give us a change in revenue, because we're dealing with R's for this marginal. When we're going from 20 to 23. Well, the setup on this is we're going to go from 20 to 23. So your starting value is this, and then this is, it tells us, increases by 3. And then we're going to have 50 minus 4x dx. Okay, so that becomes 50x minus, add 1 to our power, divide by our new power. 23 and 20. Which gives us 50x minus 2x squared. Now we plug in these values. So I got 50 times 23 minus 2 times 23 squared minus 50 times 20 minus 2 times 20 squared. 50 times 23 minus 2 times 23 squared. 50 times 23 minus 2 times 23 squared. That looks good. Enter. I get 92. Minus 50 times 20 minus 2 times 20 squared. gives us 200. What is that? Negative 108. 92 minus 200. Negative 108. That being dollars, but that's assuming I typed all that incorrectly. Let's actually type in our initial one and see if I 50 minus 4x. So I'll press my y equals clear 50 minus 4x, second trace, choose our seventh one. This will go from 20 to 23. So 20 enter, 23 enter. Where'd that come from? Go to, okay, 20. I didn't like it. Oh well. Let me tell you why I doesn't like it. Assuming my graph's correct, 50 minus 40x, it's because it goes from negative 10 to 10. I didn't really want to go into this in this depth, but if I press zoom and choose zoom out and press enter one time, let me press enter one more time. Now that should be enough, hopefully. If I do second trace and choose 7, 20 enter to 23 enter, negative 108. Now notice it's below the x-axis, and we came up with a negative. Now we're not dealing with area, so in some cases having a negative is very possible. Now I'm going to press my zoom and choose Z standard, set it back to standard viewing window. Be sure to do that. Choose zoom and then 6 for Z standard. Now remember what we're finding here. Find the change in cost for the given marginal. Nothing saying that it's not going to be negative. Okay. Now let's take a look at another one. And I don't know, let me save this, start a new page, just so I have enough room. I hate running out of room. Okay. Got f of x is equal to 9 minus x squared, 0 to 3. It says find the average value of the function on the interval. So let's do that first. And they give us a formula down below. The average value of f on AB is equal to 1 over b minus a times the integral from a to b of f of x dx. Okay. So, part A, I guess. The average value. Now that can be average cost. So think in terms of business. Average value is equal to 1 over b minus a, and the integral a to b of f of x dx. So it's going to be 1 over, this is a and this is b, so 3 minus 0, 0 to 3, of 9 minus x squared dx. So that's 1/3. And actually, I can go ahead and do this one. 9 becomes 9x minus, add 1 to your power, divide by your new power. So it becomes 1/3 x to the third. 3 to 0, or 0 to 3. Now, now we're plugging in our numbers. I say number because 3 is the only one that matters. If I so if I plug in 3, I got 9 times 3 minus 1/3 times 3 to the third, minus, and then 9 times 0 minus 1/3, 0 to the third. 9 times 3 is 27, minus 3 to the third is 27, divided by 3 is 9. And this all drops away because of the zeros. 27 minus 9 is 18, divided by 3 it would give us 6. So that's part A. Now the second part on this says to then find all x values in the interval for which a function is equal to its average value. Well, which a function is equal to its average value. So what they're wanting us to do is they're wanting to set 9 minus x squared equal to the average value. 9 minus x squared is our function. And that's equal to our average value. And then solve it. Well, I'm going to take this negative x squared to the right side and 6 to the left. I'm going to use square root property. So 9 minus 6 equals x squared. Take anything to the other side, the equals, the sign changes. 9 minus 6 is 3. Square root property. You got something squared equal to something else. You drop your squared, put a plus or minus square root around the other side. Now notice, then find all the x values in the interval for which a function is equal to its average value. In the interval is from 0 to 3. It would not include the negative version of this. So our only answer is x is equal to square root of 3. Save that. And let's look at our last problem. It says find the amount of the annuity with income function CFT. Say CFT is equal to $900. Interest rate R. R is 4%. Or it'll be 0.04. And then term T. T is 3 years. And amount of the annuity. Now the R is a rate compounded continuously. The capital T is the term of the annuity in years. And CFT is our income function. The formula for that is equal to e to the R capital T times the integral from 0 to capital T of CFT, little t, times e to the negative R little t power dt. Now I realize when we're working this, the little t is going to be our variable that we're going to work with. So let's go ahead and take a look at this problem. So the amount of annuity is equal e to the R capital T, integral from 0 to capital T, CFT, e to the negative R little t. lots of t's. Okay. So we got e R little r, or R is 0.04 times capital T, which is 3. And from 0 to 3, CFT is 900. E to the negative R, which was 0.04, times T, that's our variable, dt. I'm not very good with decimals. I think that's 0.12. Let me do it in my calculator just to see. Second mode, 0.04. I hate decimals. 0.12. So this is e to the 0.12. Now, if you got a number, you can freely take numbers in and out of your integral. So I'm going to go ahead and bring that 900 out in front. And then we got 0 to 3, e to the negative 0.04 t dt. Well, this is a u substitution. We're going to let u equal to negative 0.04 t. The derivative of that is going to give us negative 0.04, and then we throw in our dt. Okay, so we got 900 e to the 0.12. Now we need a negative 0.04 inside, so we'll offset it by putting a negative, or 1 over, negative 0.04 out in front. 0 to 3, negative 0.04 e to negative 0.04 t dt. Because a negative times a negative is positive, and this times that gives us 1, because they're reciprocals of each other. Okay. So this right here is going to replace this with u. The negative 0.04, and the dt is both going to be replaced by du. Let me put this into a single fraction. We've got negative 900 e to the 0.12 over 0.04. And this will be t equals 0, and t is equal to 3. And then this becomes e to the u du. This negative 900 e to the 0.12 over 0.04. The integral of e to the u is e to the u. Now let's plug our u back in. Up here we said u is, oh there it is, negative 0.04 t. So negative 0.04 t, 0 to 3. That gives us negative 900 e to the 0.12 divided by 0.04. And then that gives us e to the negative 0.04 times 3 minus e to the negative 0.04 times 0. Which gives us negative 900 e to the 0.12 over the 0.04. E to the negative 0.12, 0.04 times 3. And 0 times anything is 0, and e to the 0 is 1. So that's minus 1. Well, at this point, we probably want to plug it into our calculator and see what we get. Negative 900, and then e, so second ln, 0.12, close parentheses, divided by 0.04, beginning parentheses, e, second ln, to the negative 0.12, close parentheses, minus 1, close parentheses, enter. And the amount of annuity is equal to 2868.68. Barring any basic math error I made there. Let's go check myself. Now, you have to be careful when you're plugging these into your calculator. In order to accurately put in your calculator, you have to have everything inside of the integral. So we're going to be looking at this from 0 to 3, and I'll move the e to the 0.04 times 3, 900 e to the negative 0.04 t dt. So you want all that inside. Okay, so I'm going to press my y equals, clear, and I got e, so second ln 0.04 times 3. Try it again. There we go. 0.04 times 3. Screwed up right from the beginning. Times 900 times E, so I do second ln, and then negative 0.04, and it says t, but I'll put x, close parentheses. Now let me do a second trace and choose my integral one. Now this is probably one I would expect to see a rounding error pop up, but let's see, probably perfect. 0, 3. 2868. 0.68. Perfect. Yeah, I guess I can't predict them, can I? I think that was the last problem. Yes, it was. So let me save this. To get a job as a fortune teller as good as I'm able to predict things. And time for that to blow up. That's okay, I'm done with that. And I'll go ahead and stop the recorders.